let's go over an example. Let's say we flip a coin. The probability of getting a head is P. The probability of getting a tail is 1 minus P, where P is a number between 0 and 1. Now, we flip the coin repeatedly until we get a head. As soon as we get a head, we count the number of flips required to get the first head. We are also fixing a positive integer n. So this positive integer n is going to be the maximum number of flips that will be allowed. What it means is that if we get tails on the first n-1 flips, then we stop after the nth flip, no matter what we get on the nth flip. Okay, so let me erase these t's. I will need this space later. So x is the number of flips. So what is x then? Well, x is the number of flips required to get the first head. And if we get tails on the first n-1 flips, then x will be n. So the possible values of x would be 1, 2, up to n-1, and n. Now, what we want to do is find the probability that x is equal to I, where I is one of the values 1 up to n. In order to find the probability that x is I, we need to look at two cases. The first case is when I is 1, 2, up to n-1. In this case, the probability that x is I, so I is the one of the numbers between 1 and n-1. In that case, the probability that x is I is the same as the probability of the event that we obtain tail on the first I minus 1 flips, and then we get a head on the ith flip. Okay, and so what is that? Well, that's the same because the trials are independent. We know that this should be the same as the probability of getting a tail from the first flip, probability of getting a tail from the second flip, probability of getting a tail from the I minus first flip, and probability of getting a head on the ith flip. And each of this number, the probability of t is 1 minus p, so I have 1 minus p, 1 minus p, 1 minus p, and the probability of h is p, which is going to give me 1 minus p to the I minus 1 multiplied by p. Let me make some room right here. Okay, so now we look at the other case when x is n. Now in the case x is n, what can happen? Well, in the case x is n, it means that the first I minus 1 flips result in tail, and well, there are two possibilities for the nth flip. You can get a head or a tail. So when x is n, then the probability that x is equal to n is the same as the probability of the event that I get tails on the first n minus 1 flips, and then I get a head on the nth flip, or I get tails on the first n minus 1 flips and a tail on the last flip as well. And well, let me write it this way, this or this. And the two events here are disjoint, so I can write it as the probability of the event t dot 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 t and h on the nth flip plus the probability t dot 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 t and t on the last flip as well. Now the flips are independent, so this is the probability of t dot 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 probability of t times the probability of h plus this is the probability of t dot 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 probability of t, which is equal to 1 minus p times dot 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 1 minus p n minus 1 times, and then p plus 1 minus p dot 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 1 minus p. Let me make some room here. Okay, so then this is equal to 1 minus p to the n minus 1 times p plus 1 minus p to the n, because all n flips were tails. Okay, so that's it. So that's the other case. Alright, so go ahead and look at this problem carefully and make sure that you know what's going on. See you in the next video.